Welcome to Brain Vision.
For part A, because there is no slipping between the wheels, the tangential component of the linear acceleration of each wheel must be the same. So we can say that the tangential acceleration of the smaller wheel will be equal to the tangential acceleration of the larger wheel. And so we can then say that the angular acceleration of the small wheel times the radius of the small wheel will be equal to the angular acceleration of the large wheel multiplied by the radius of the large wheel. We can then say that the angular acceleration of the large wheel will be equaling the angular acceleration of the small wheel multiplied by the radius of the small wheel divided by the radius of the large wheel. And we can solve. This would be equaling 7.2 radians per second squared. This would be multiplied by 2.0 centimeters divided by 21.0 centimeters. And so we can say that then the angular acceleration of the larger wheel is equaling 0.686 radians per second squared. This would be our answer for part A. For part B, we're going to assume that the pottery wheel starts from rest, and we're going to convert the speed to an angular speed and then use equation 10(9)a rather. And so we can say omega will first equal 65. We can say 65 revolutions per minute multiplied by 2 pi radians for every revolution, and then multiplied by 1 minute for every 60 seconds. This is giving us 6.807 radians per second. And we can then say that time would be equaling the final angular acceleration minus the initial angular acceleration we know to be 0 divided by alpha. And so this would be equaling 6.807 radians per second divided by 0.6857, we'll round at the very end, radians per second squared, and we find that the time is going to be approximately 9.9 seconds. This would be our final answer for part B. That is the end of the solution. Thank you for